Well, welcome back. In this lesson, we are going to talk about bisectors and triangles. And specifically, we are going to talk about perpendicular bisectors in this lesson. The next lesson, we'll talk about angle bisectors. So first of all, we have some new terminology that we need to kind of get out of the way. And the first one is the term concurrent. And whenever we have the intersection of three or more lines at a single point, we say that they are concurrent, and the point where they intersect is called the point of concurrency. So that leads us to our theorem, our concurrency of perpendicular bisectors theorem. And that theorem says this: if you have the three perpendicular bisectors of a triangle and they intersect at a single point, then that point where they intersect is equidistant from the vertices. So in red in this picture, you'll see the three perpendicular bisectors of each of the sides, and P is the point of concurrency. And basically the theorem says P is equidistant from A, B, and C. So the bluish green dashed lines here are equidistant from point P. So the point of concurrency of the perpendicular bisectors of a triangle has a special name, and it is called the circumcenter of the triangle. And that circumcenter is equidistant from each of those vertices. That's what our theorem said. So we can use the circumcenter as the center of the circle, and we can circumscribe that circle about the triangle. So we could say that the circle is circumscribed about the triangle. So we can have three different scenarios. The scenario that I just showed you, where the perpendicular bisectors intersect inside the triangle, that happens when you have an acute triangle. But that circumcenter could also occur on the triangle. When you have a right triangle, that's what you'll get, is that circumcenter is actually on the triangle. And with an obtuse triangle, that circumcenter is actually outside of the triangle. So, finding the circumcenter of a triangle. Here we have an example that gives us the three coordinates of a triangle, and they want us to find the coordinates of the circumcenter. So our first step in this one, we're going to graph this triangle, which I have shown you here. We want to find the midpoint of two of the sides. We found the midpoint of side OP, and we found that to be 0, 3. So that's the point right here. It's not drawn in the diagram. The second step was to find the midpoint of side OS, and that was 2, 0. And then we went ahead and drew vertical and horizontal lines, and the point where those two lines intersect will give us the coordinate of our circumcenter. So step 3 is to find that point of intersection of the two perpendicular bisectors, and in this case its coordinates were at 2, 3. So the circumcenter has coordinates 2, 3 in this example. Here's an example for you to try. What are the coordinates of the circumcenter of the triangle that has those three vertices? I've gone ahead and labeled each of those vertices A, B, and C and drawn the triangle for you. So go ahead and pause the video and see if you can come up with the coordinates of the circumcenter on your own. Alright, I hope you gave that a try. Let's go ahead and take a look. First of all, I found the midpoint of segment AB, and I went ahead and constructed that line. Its coordinates, the midpoint coordinate right here, were 6, 7, in case you found that. And then I found the perpendicular bisector of side BC, and went ahead and drew that line. And this midpoint had coordinates 10, 5. So then we need to find the coordinate right here of the intersection of those 2 points. So the intersection of those 2 points would be the coordinate. Let me go ahead and write this down for you. It looks like it's going to be 1, 2, 3, 4, 5, 6, 5, I believe. Let me just verify that. So we go over 6 and up 5, 1, 2, 3, 4, 5, and that it gives us, those are the coordinates of the circumcenter. Here's an example from like a city planner kind of a thing. A town planner wants to locate a new fire station, and he wants it to be equidistant from the elementary, middle, and high schools. So where should he locate the station? Well, here we have a picture of what the town looks like, and he wants to locate the fire station somewhere equidistant from these 3 schools. So to figure out what that point would be, we would need to construct a triangle out of vertices H, E, and M, and then find two of the perpendicular bisectors and find that point of concurrency. Well, over here at the right is the solution. So if you go ahead and draw a triangle with those 3 points, the high school, elementary, and middle school, and then find the perpendicular bisectors of two of those sides, then you can go ahead and find point P, which in this case happened outside of the triangle, and that is where you would want to locate your, what are we looking for? The fire station, right? Yeah, so that's where the fire station should go, is at point P. All right, here's a lesson check for you. Find the coordinates of the circumcenter of the triangle that's given and bring the answer to that question to class. See you next time.